Hello everyone and welcome back to another video from Netmaster Zone channel and the second video of the FortiGate series. Let's directly go to our lab and let's just 2 minutes. I'm going to discuss actually what we did in the previous video. In the previous video we configured the high availability between these two FortiGate, primary and secondary, and also we configure a redundant interface and add port 5 and port 4 in that redundant interface and connect that with this switch. Now this port is a layer 3 connection between the FortiGate and also to the switch. And also we configure some route here, and now we are able to ping from this to PC to our FortiGate from inside. And also we configure this 2 ports for the outside interface, and but we don't have any route here, and we are not able to go to the internet for now. Here in this video, first of all, let's first test this high availability that we created in the previous video. I want to make sure that this high availability is working here in this two FortiGate. Let's go to our management PC. Let's log in. Okay, what we are going to do in this video, we are going to configure the SD-WAN functionality here in this FortiGate between this port 1 and port 2. When one of this ISP is down, the other ISP should take the place and send and receive the traffic. And also next we are going to configure a internet policy, internet access policy to actually filter some website through internet. When this for example this Windows wants to access the internet, it should do some filtering here. And let's see, and during the configuration we will see what else actually, what more detail that is required to configure in this two FortiGate here. Okay, let's go to our interface, FortiGate interface, and here first of all let's go to the system and to the high availability HA. And here you see that the primary is 128 and the secondary is 1. It means that if I reset this one, this should become the primary. To test this configuration, let me see. If I remove this port, that it will be problem because we cannot connect it back, and we need to turn off this FortiGates. Because of that, let's go to this FortiGate primary and let's restart this machine. Admin and password. For restart, let's run execute reboot and let's press enter. Before actually rebooting this, let's go to our VPC and run a ping here. Let me put it down. I'm going to run a ping. I think this VPC is already, I have interface, yes. And let me run a continuous ping here, and now let's restart our FortiGate by pressing Y. Yes, and you see that it's just I lost one ping, and after that the ping comes to normal, and in some seconds this interface should be log out, and next time when I log in I should log in with the this FortiGate secondary should become the primary, should take the primary rule here. Yes, it's just logged out. Let's log in again. You see that I'm still connected with 192.168.1.1, but this time the FortiGate, you can see that the FortiGate S is the primary here, HA primary. And if I go to the system and in HA, you can see here that this primary now is synchronized and it's become the primary FortiGate, but it doesn't show the other one. In a moment when the other one comes back, it should comes to this list also. Yes, you can see that the other FortiGate, it also comes here and it's become the secondary. Still the priority of this is 128, but it goes to the secondary state because it's the uptime of that is only 43 seconds. By default, it's doesn't actually preempt to become the primary. And in normal, if we deploy this topology like this, it means that we have two ISP here, and one port of each FortiGate is connected to each ISP, and also all this these two FortiGate, of course, they are same. They have the same memory, same RAM, everything, and also the switch is same. The link is everything is same. Then it doesn't make any sense to just switch it back to change the FortiGate primary, FortiGate P as a primary, because again it will just lose a one ping here, and it will lose the session, and it will disconnect our network for a couple of seconds. Because of that, by default, the FortiGate doesn't have any preempt by default. But we can actually change this. We can change this and say to the FortiGate, when the primary comes up, it should be preempt, and it should become the primary. For that, we don't have any configuration actually in the graphical mode. You can see here there is nothing here about the preemption of this FortiGate. Because of that, we need to do this configuration in the CLI mode. Okay, before going to the CLI, let me show you something here. Here you can see that we have another configuration here, that is unicast ART-bit, because by default actually this FortiGate is doing the multicast to send the ART-bit to the FortiGate, but we can actually give IP address of the other FortiGate here and makes this sending and receiving the FortiGate the heartbeat actually as a unicast. But here in this lab we are not going to use this, and also the management interface reservation, this one is also it's used for we are going to reserve our access to this management interface. But by now we are not connected through this inside interface because we don't have any monitoring interfaces here. We will configure this later, maybe in this lab, but for now let's go to our FortiGate CLI, and let's try to configure the preemption between these two. Let's go to configure system HA. And here if I type show command, you can see that it shows me the configuration of this. The group name is group 1, and set mode is active passive, and set the HDB, this is the heartbeat ports, that is port 6 and port 7 with the heartbeat priority of 50, both of them. And also we enable the session pickup, and set, you can see here the set override is disabled. It means that if it's reset, it will not preempt to become primary here. And also if I type here question mark, you can see some other configuration that it's already here. For example, we have a group name here, but we don't have any group number. Let me set interset, and you can see here that this is the group ID. By now we only have one FortiGate availability cluster here, and because of that, by default the ID is 0, and it doesn't need to enter any number. But if we have others groups that it's already involved in this topology and with this FortiGate, then we should assign a group ID for them to say that, for example, these two FortiGates belong to one of this ID. Okay, to makes this preemption, let's enable this, set override to enable and end. With the end command, this configuration is saved and will apply on the FortiGate. And now let's go back to our FortiGate and see if it's trying to start to preempt to become primary or not. I think it did that because we just logged out, you can see, and now the other FortiGate, the FortiGate primary, become primary here. Let me log in. And here in this interface, let's wait for it. Let's go to the system and check the HA. And even in the first screen, you can see that FortiGate P, it's become the HA primary, and it means that it just preempt and it takes its rule back from the FortiGate S, from FortiGate secondary here. And here in this interface, we should be able to see that this interface, this FortiGate, it become primary again. And if we go to our virtual PC, here we should see a ping that is lost during this switch between these two. I cannot find it here. Okay, here you can see that this FortiGate with the priority 128, it's become primary again. And this time, if I reset that, let me reset this again. Execute reboot. Yes. Let me bring this interface. We can see the timeout. Okay, this time even we didn't receive any timeout, and it's a good sign. I think it's because of this session pickup that I enabled that in the interface. Yes, just the system restart, and we didn't receive any timeout. It means that the session pickup is working, at least here. You just have the same session, and when it switches back to the other FortiGate, it's used the same session between this VPC and the FortiGate. Then there is no any actually reinitiate the session, then it's just continue the ping without any interruption. And here let's if this interface come back, let's wait here. It will log out very soon because we just switch back to the FortiGate secondary here. And when we log in again, it should switch it back to FortiGate primary. It means that this time it will preempt to become the primary here. Let's wait for this. Yeah, you can see here that we just logged out, and if I log in, I think it will go back to our FortiGate P because it takes some time. Yes, it's again get back to FortiGate P. It means that it's already switched to the FortiGate primary, and FortiGate P just claim its role as a primary, and it takes the rule back. Okay, we see here that our let me cancel this. Our high availability is working very good here, and there is no problem. And now let's do something. Let's configure our SD-WAN interface here, and then we will access the internet using this interface SD-WAN. Why SD-WAN? Because as you see here, we have two ISP, ISP1 and ISP2, and if one of this ISP is down, then the other ISP should take the responsibility to send and receive the traffic. And in this case, if we only connect this port, for example port 1 to this ISP and port 2 to this ISP here, then switching between these two ports will be manually. And if this for example the primary port is port 1 and it's used for traffic here to ISP, if this ISP1 is down, then the port 1 will not be able to access it, and it needs someone to log into the FortiGate and manually change something here. For example, remove the route here and add the route to this port to send the traffic to the internet. In this case, it will take of course a lot of time to switch between these two, but this SD-WAN here just helps us to makes everything very fast and automatically without any try from the administrator side to change this configuration. To configuring this SD-WAN, let's first go to the network, and let me show you that the interfaces we already have here. We have port 1 and port 2, and both of them is connected to our ISP here. And also, as you know, that this is high availability here. It means these two ports we have the same in other FortiGate, and anything changes here will be replicated to that FortiGate also. It means that logically, actually, we have one FortiGate, not two, but physically they are divided into two devices. Okay, we have port 1 and port 2. To configure the SD-WAN, let's go to the SD-WAN zone, and first of all we need to create a SD-WAN zone here. Create new and SD-WAN zone. Let's name that SD-WAN internet. It shows that this interface just goes into the interface because we are going to also use this SD-WAN for the remote access, not remote access, to site-to-site VPN, and then I'm going to give them a relevant name. This is SD-WAN internet. It means that it is connected to the internet. Let's save this, and now let's go and this time let's create a let's add members to this SD-WAN internet. Which port? Port 1, that is connected to ISP1. I'm going to add that to SD-WAN internet interface, and the gateway for port 1 is 172.16.10.1. This is the IP address that is configured here in the ISP1, and 2, of course, we configure that in the FortiGate. Okay, let's save this, and let's add another member to this zone, and this time we are going to add ISP2 port 2 added to internet SD-WAN internet, and gateway for this is 172.16.20.1. And of course we have a cost here. We will speak about this later, but by now let it be 0. Okay, now we have interface SD-WAN, and it's up, and you can see that it's trying to send and receive the data, but we don't have any route still, and also we don't have any policy for this to send and receive data. Let's first create a route, then a policy, and after that we will come back and configure this SD-WAN rules here. Let's go to the routing, a static route, create a new. We are going to send everything to the internet, then the destination of course is the subnet of everything, and the gateway address, we are not going to use the address here because we are now connected to two different interfaces, and every interface has its own gateway. Then we are not going to use any IP address. We only have one IP address here, then we cannot use both of them. Instead we are going to use this interface. It means that we are going to send the traffic to this SD-WAN interface here that we created before. It just show me SD-WAN here, but the name of this is actually SD-WAN Internet. And in the new version, Windows OS 7, this problem is solved, that you don't see this SD-WAN. You see the name of the interface that you created before. And if you have any comment, of course we can have here, and let's save this. Okay, now we have a route 00, and all this traffic will go to the internet. Let's go back to our SD-WAN zone, SD-WAN interface port, and now you can see here that we have some download and upload of the data actually here in this. And you can see that the first port, this ISP1 is used more than this the other port here in this interface. Okay, now let's go and create a policy to be able to ping to the internet using one of our virtual PC here or our Windows. Let's go to firewall policy, and here you can see that we only have one, and that is implicit deny. It means everything from any source to any destination always is denied. Let's create one, and let's name that, for example, internet access. Incoming interface is the interface inside net. This is the virtual interface that we are created here. This is the redundant interface, and it's connected, its member is port 4 and port 5. Let's select this one. Let me show you in the diagram. Actually, this interface is this two interface. This is incoming interface, and the outgoing interface of course is the SD-WAN. We are going to send this information to SD-WAN. If you see here, we don't have any port 1 and port 2 because they are a member of this SD-WAN internet. And source IP address, we don't have any source here. Let's create a source. It's an object network that we are going to create. Let's name that inside net, and it's a subnet of 10.10.0.0/16, and interface any, it's okay. Let's have this as a source, and the destination of course it's going to internet. Internet is very big. Then let's select all, and the services also should be all, any service. Here we have some other information. You can see we have NAT here. Of course, it's very important that when we are going to send the traffic to the internet, we have to NAT it here. And this NAT option is the actually this is the only place you can NAT traffic to the another from one zone to another zone, and that is when you are creating a firewall policy. Else there is no any option here for creating NAT. Let's turn it on because we are going to NAT from inside to the outside. And of course there is some information here. The pool, we are going to the send it to outside interface, and if we have any pool reserved, of course we can use it here. The protocol option, let it be in the default. We can create some protocol option here, and here you can see that this is the security profiles, the antivirus, the web filtering, DNS filtering, and so on. By default all of them is off. Let it be like this. We will come back for this and check this option separately, and anything else is okay, and enable this policy. Let's save this. Now we should be able to ping from this virtual PC or from this Windows to the interface, to the internet. Let's ping it. Ping 8.8.8.8. No, I'm not able to ping. I think the problem is something should be here in this switch. I'm not sure if this switch has a default route to the correct gateway. Show run section route. Yeah, actually you see that it has a route to 13, but here our interface is 2. 1 is here, 2 is configured here. Let's remove this one and configure it back to correct gateway. This is 2. Let's save this configuration, and this time we should be able to ping to the internet. Yes, you can see here that we are able to ping to 888. It means that traffic that goes through this VPC, through this switch, through one of this FortiGate and one of this ISP, and goes to the NAT. This is actually, it's connected to the interface. I have NAT here, and NAT is in this ISP here, and it's going to the internet. This is the real internet actually, not simulated. Okay, let's actually do something. Let's trace this 888 and see this traffic goes through which ISP, through ISP 1 or through ISP 2. Trace to 8.8.8.8. Here goes to the gateway, and go to the one of this FortiGate, and now you can see it's go through 172.16.10.1, and that is the ISP1 that we configured here. By default is using this ISP, but we have two interfaces, two ISPs here, and it's SD-WAN. If this one of these interfaces is down, this ISP is down, the other one should take the places. But for now the problem is here that we don't configure any FortiGate SD-WAN rule here, and if for example this interface is down, then the FortiGate doesn't know this interface is down, and to redirect the traffic to other ISP. And even if I turn off this interface, let me do that. Let me turn off this interface E0 by 0. And shut it down. Now if I try to ping or trace through virtual PC, let me trace. You can see it goes to this FortiGate, to the ISP1, comes to this interface, but this ISP doesn't have any access to the internet. Then the ping is dropped here, and it will not continue. And if I ping it, you can see that it's timeout, and just give me timeout reply, something like that, and I'm not able to ping it. It's because we don't have any SD-WAN rule here. In this case, now we need to switch this interface manually, and it's not a good practice, especially when we have the SD-WAN functionality in this device. Okay, let's go back to our SD-WAN, to network, and this time let's go to the SD-WAN rules. Before creating any rule here, let's go to the performance SLA. service layer agreement, and let's create a SLA and rule SLA rule here actually to check what we are going to check here. Let me try actually explain this, what this SD-WAN rule do. This when we create any rule in the SD-WAN, the FortiGate is trying to check some factors here in these two links and decide which of them has a better performance and better quality to send this traffic through. And these factors actually belong to us. We can select that which factor, for example jitter or bandwidth or packet loss or something, that we test in these two ports and decide which port has a better quality to send traffic through that. And here in this interface, this performance SLA, actually we can create this. You see here the packet loss, latency or jitter. We can select one of this to decide which port, which path has a better quality. Let me create that. Create one. You can see by default we have some here. For example, for AWS, for Amazon Cloud, DNS, Gmail, Google, and also the FortiGate Cloud and so on. Let me create one. I'm going to name that, for example, let's name this link test. What I'm going to do, I'm going to ping a link. I'm going to ping 8.8.8.8 and let's use another server also to make sure that if, for example, this 8.8 is face problem, we should have a backup for that. Let's do 4.4.8.8 also. Let's ping these two IP. These two are the public IP address inside the internet, Google DNS, public DNS address. And now let's do this for all SD-WAN members. And actually I'm looking for a function that the FortiGate 7 has, but here it's not available. And okay, let's continue. I will show you that in the FortiGate OS 7 that is different. It has some other options here that we can decide. But here SLA target, we can test this SLA target. What is the SLA target? For example, here we are going to ping 888 in this internet, and this FortiGate check the quality of this target SLA. And for example, from this path is as a for example 1 millisecond, and from this path is 2 milliseconds. That it will decide to go through this path to the internet. But I'm not going to use this target SLA here for now. And this one is the link status. It's going to check the interval every 500 milliseconds. It's try to ping this to IP address. And if it fails 5 times fails, then it will switch that to the other link. And again it start to check the primary link, and if the primary link come back and after 5 times check, it will switch it back to the primary link. And this is the configuration that this update the static route. It means when the path it comes back, the static route here automatically will enabled back to the in the primary path. Okay, let's save this. Now we have a performance SLA. Let's go to the SD-WAN rules and now create a rule for this SD-WAN interface that we created. You can see that there is one rule here by default, but this is I think it's disabled. We are not going to use this. Let's create another one. let me name that again link test. This time I just write that in capital letters. Source address, from which source we are going to test this from the inside net. It's a let me see if it show it here. It's a object network that we created, and it's 10.10 I think. Yeah, it's 10.10.00/16. This is the source. We are going to check this. And user group, I'm not going to use any user group here. Destination address, to all internet. And here you can see which protocol, TCP, UDP, or any, or we can specify. We are going to check any here, and the rest let it be the same. The internet, this is the services that we are going to check, and also if there is any application that we are going to check, we are not going to use that. And in the outgoing interface, we are going to check the best quality. Which interface has the best quality, and from which interface here? We are going to check the interface port 1 and port 2. These two interfaces will be tested with this condition to make sure which one has the better quality to send the traffic through. And the measure SLA, this is the performance SLA that we created before here, and which quality that we are going to quality criteria that we are going to test. Jitter, latency, packet loss, and downstream, and so on. Let's select the latency, and this is by default in the FortiGate, and the status of this rule is enabled. Let's save this. Now we have this rule here, and you can see it's a tick here. It means that now this link is used for sending and receiving traffic. The reason is because we turn off, if you remember, we just shut down this interface, and now this interface is used for the sending and receiving the traffic. And if I go here and try to trace, you can see this time that this traffic, no, it's going through actually it's going through 172.16.20.1, and it's configured here in the ISP2. It means that it just switched back to the ISP2. And now if I go to the SD-WAN zone, here you can see that the traffic in the port 2, it's become bigger, and this diagram is showing the download and upload, and port 2 is the bigger one, and every time if I refresh this, it should become bigger and bigger. By now I don't have any traffic here. Let me try to ping 8.8.8.8-t, a continuous ping to generate some traffic here to the internet. And if I refresh this page, you can see this percentage, and also this diagram will change, and all the traffic goes through the port. You can see that port 2 is become bigger, and all the traffic now go through this port 2. And if I go to this SD-WAN rule here, here also we should see some information. No, not in the rule, in the performance SLA. You can see here that the port 1 is down, and for both of this IP address is not able to ping it because this port is shut down. Let's go back to the ISP and try to turn on this port. No shut it, conft interface is 0 by 0, and no shut. Now this port is come back, and after some seconds this information will change here. Let me refresh it. Now you can see that this port is also comes up and it's showing the latency and also the jitter in the millisecond. 2.6 millisecond for jitter and 2.89 millisecond for port 1 and port 2, the jitter for port 1 and 2. And now if I try to trace it, let me see that if I trace this time, it's going through. Again, it's go back to port 1 and it select the port 1 as a primary port. And this time if I just shut down this port again, conf t, shut down, just trying to test. Now this port is down, but if I trace it, you can see in the just in a second it's switched back to the port to the other ISP. And if I put a continuous ping here, 8.8.8.8 and no shut it, let me see if I see any packet lost here when the port comes up. No packet lost in the switching. And if I shut it down, yes, you see that we just lost 2 packets to switch it to the other port to access the internet. No shut, but for the comeback, I think it doesn't lose any packet. When it switches back to the port, it's okay. No, there is no packet lost here. And if I trace that, yeah, it's going through port ISP1. Okay, I believe for this video it's enough. We configured the SD-WAN. Let's go back to our topology. Okay, in this video what actually we did, we configured the SD-WAN in these two FortiGate and create a SD-WAN virtual interface, add these 2 ports as a member, and also we configure some routes to send this traffic to the SD-WAN virtual interface, not to the gateway of this port, and sending the traffic to the interface. And also we configured some firewall policy to give access to the internet for this PC and also for these 2 servers here to the interface to the internet. And we configure some SD-WAN rules to check this these 2 ISP to make sure that which of them has a better quality to send and receive the data. And then if any changes happen to one of this interface, the other one will automatically take the place with only 2 ping lost. And it's very fast, and even the user doesn't identify that it's something happened in the switching between these 2 ISP. But without this SD-WAN, it will be a lot of effort to change this interface from one ISP to other ISP. For example, to change the route from this port to this port, and the administrator, of course, it will take some time to change this configuration. Okay, for now let's finish our video here, and in the future video we will speak about this because we are already in the part that we configure this FortiGate policy, internet access policy in the FortiGate. We are going to speak about the internet filtering, and next we will go for the access and to configure this Radius server. Okay, for now let's finish our video. Thank you for watching. Please like and subscribe, and please let me know your question if there is any. Thank you for watching, and see you in the next video.